What's up, Algebra 2 students? Day 4 homework on complex numbers. Complex numbers are imaginary numbers. We're going to get them as solutions whenever we have a situation where, say, you are graphing x squared plus 4, you could visually see we don't have any x-intercepts. We used to say no real solution. Some of you might have said no solutions. But turns out there are solutions. The square root of -4 is a solution. Now, this is not a real number. How do I know it's not a real number? Like your calculator can tell you. You could also think about it. What number times itself gives you -4? Well, I don't know of any number times itself that gives us -4, so I have -4 plus 4. My calculator tells me the square root of -4. Non-real answer, okay? It's not a real number. It's more of a concept. It's an imaginary number, but it is a solution. So here we have imaginary solutions, okay? So we're going to have to get these imaginary solutions, and we're not going to write them as like the square root of -4 and say that's our solution. We're actually going to simplify this. We're going to say, well, isn't that the square root of 4 and the square root of -1? Kind of like how we simplified on day 1. Yeah. Well, the square root of 4 is 2, and we're going to say the square root of -1 is I. It's kind of the way that we signify that we are talking about an imaginary number, something that we can't think of, a number times itself that gets a negative, okay? And it's not really something we can think of. It's something we can't see. We can't see this number. So whenever we have the square root of -1, we get I. So what we're going to do with these square roots of negatives to write them in simplest form is we're going to write them as a square root of a positive, whatever the number is, times the square root of -1. The square root of -1 is I. Your calculator can't say this. You just know what it is. And then we just look to simplify the square root of the number. This is when we go through the process of, step 1, is it a perfect square? Check. I feel like we should have like a flow chart for simplifying where it's like, is it a perfect square? Good, you're done. Is it not a perfect square? No. Can you divide that by the number inside that by a perfect square? Let's remember all of our perfect squares. I'll put them down here. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. And you can keep going, just like what's 9 times 9? It's 81. The square root of 81 is 9. These are the numbers you could plug into your calculator with a square root, and you get a whole number. All other numbers, you get decimals, okay? Let's take the square root of 75. For this one, we were able to square root. Boom, we got a perfect number. Boom, we're done. For this one, first I'd start by writing this as the square root of 75 times the square root of -1. Can you take the square root of 75? No, it's not one of these nice numbers, but you could also check. Okay, next step. What is the biggest one of these that divides evenly to the number 75? Okay, this is step 2. Try 36. No, it doesn't work. Try 25. You want to find the biggest one. 25 works. That means 25 times 3 is 75. So root 25 times root 3 is root 75. You still have the root -1. The reason why we do this is because root 25 is 5. 5 stays. Root 3 cannot be simplified. The square root of 3 is just the square root of 3. We would leave that alone. And the square root of -1 we say is I. This is the simplified way of producing this imaginary number, the square root of a negative, which we can't do. Okay? Square root 108. Again, we'll start by just writing it as root 108 root negative 1. Let's try to divide 108 by some perfect squares. 81. I should have checked, is 108 a perfect square? No. Okay. Start dividing. 81 doesn't work. And I'm not doing the root. I'm taking like the actual number. 64 doesn't work. 49 doesn't work. 36 works. So root 108 is root 36 times root 3. 36 times 3 is 108. So root 36 times root 3 is root 108. The square root of 36 is just the number 6. 6. Root 3 stays. The square root of negative 1 is I. And this is our simplest form. I love how I put this one down. The square root of 5, negative 5. Well, it's the square root of 5 and the square root of negative 1. Can you take the square root of 5? No. Can you divide 5 by any of these numbers? No. 5 can't be divided by 4, right? So, guess what? Root 5 stays as root 5. You can't change it, but it's root negative 1 that turns into I. Okay? 28. Can I take the square root of 28? No, it's not one of my numbers. I can double check. Can I divide 28 by a perfect square? Well, not 16, not 9, but 4 works. 4 times 7 is 28. Root 4, root 7. Oh, I forgot the first step, which is I should have done. Root 28, root negative 1. Root 4, root 7, root negative 1. Root 4 is 2. Check with your calculator. Square root of 4 is 2. Root 7 can't be simplified. Root negative 1 is I. This is what we would say would be like a potential solution to one of these quadratics. Okay? So now we're going to have a situation where we're solving quadratics, whether it is using square roots by isolating the square or using square roots by using the quadratic formula. Remember, just if you have a standard form, if you have an ax squared plus a bx plus a c, you should be using the quadratic formula. If you just have x squared or quantity x squared, you should be using square roots. If there's no like x squared plus x plus something. So like identify what you have. Here, I mean, we can just look at 7, 8, 9, and 10 and say, oh, this one just has an x squared. I'm going to use a square root. Oh, this is a quantity squared, and that's it. This is vertex form. This is typically used for, difference of squares, DOS, as some teachers called it, difference of squares, or vertex form. And this is used for standard form. Okay, this is vertex form. It's just got a square, so I'm going to use a square root for this one. This is standard form. It's ax squared plus bx plus c. So this is where I'm going to use the quadratic formula, which I didn't put down on your homework, but you had it in your notes. Okay, I'll write it down. Going to use the square root again here. Standard form, quadratic formula, square roots, quadratic formula. Okay, and that's it. These 10 these like 4, 8 solving. It's really the same stuff as what we did on day 2, day 3. It's just we're going to have i's, these imaginary numbers and solutions. Okay, so let's do some of the square roots first. I'm going to do the 3 square roots, and then I'll do like 2 quadratic formulas. So 7, 8, and 10 first. Isolate the square root, or isolate the square. Whether it's x squared or parentheses squared. you're going to have to do it like you would solve an equation. Subtract or add and then divide. And I get negative 196 divided by 4. Negative 49. Square root both sides. Now, we didn't see this in the 1, 2, 3, 4, 5, 6, but when you square root both sides, if you're solving an equation, you need to understand there could be two solutions. There could be a plus or a minus. Okay? So that's what we got. The square root and the square on this side goes away. I would write this as root 49 root negative 1. Okay? But can we simplify that? Oh, the square root of 49 is a nice number. It's just 7. So I would change the square root of 49 into 7. I would change the square root of negative 1 into I. Positive 7i and negative 7i, like root 49, root negative 49 and negative root 49, negative root negative 49, work in the original equation. These are the solutions, these imaginary numbers, okay? Let's get ready to simplify things. So I'm going to write down our perfect squares. I'll do it up here. We know the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Okay, and we can keep going. Usually we don't have to get that high. All right. Isolate the square. Get the square by itself. Well, add or subtract, then multiply or divide, depending on what's going on. Square root both sides to get rid of the square. Okay. Now this is going to be different. Again, over here, the square root and the square go away. So the parentheses square, gone. They cancel each other out. Here, this is root 5 root negative 1. Well, we talked about how root negative 5 can't simplify. So we have just root 5i. Now we square rooted both sides. Don't forget a plus or minus. Okay, so we have plus and minus root 5i. Now remember what we do here. We finish off by getting rid of the 3. How do you get rid of the 3? Well, it's x plus 3, so subtract 3. Subtract 3. You may write this in any way, but there is a standard form where we put the number first, plus or minus the amounts of imaginaries we have, root 5i's. I'm adding negative 3. I'm adding negative 3, which is why I can put negative 3 here, plus or minus root 5i. Really like adding negative 3, so I could put it there. We can also subtract at the end, but that's not considered standard form. So let's look at this one. I subtract 16, subtract 16. I square root. I got a square root of a negative. Again, like guys, if you're not sure what you're doing, you can use your calculator. Your calculator is going to lead the way. Square root of negative 16. Nope, can't do that. But there's still a concept. There's still a number, an imaginary number that is a solution. Okay? The square root and the square go away. We need a plus or minus, and we have this root negative 16. I'm going to write it as root 16 root negative 1. I know that the square root of positive 16 is 4. So I have 4, and then the square root of negative 1 is I. Now this is a concept. It's like an imaginary number. So if I add 1 to it, I'm not going to add 1 to 4. I'm not going to add 1 to negative 4 like I would for the other situations if this was like x minus 1 squared minus 16. Instead, I'm just going to leave my answers like this. These are my two solutions, one plus 4i and one minus 4i. If I plugged it in here and squared it and added 16, I'd get the right answer. Okay? So those are good 3 square roots. Let's do quadratic formula, 2 quadratic formulas in a row. Now, what's great about this, and maybe this is good for your like your midterm review, is you see a quadratic. Last unit, we learned how to factor using this whole X box. A times C is 39. B is 12. Just because we don't have two numbers that multiply to get 39 and add to get 12 doesn't mean there's no solutions, okay? This is where like the quadratic formula is actually crucial in knowing whether or not truly there are no solutions, no real solutions, or two imaginary solutions. So let's use the quadratic formula here instead. X equals the opposite of B over 2a. I like using that parentheses around here. Plus or minus, on the top, the square root of b squared minus 4 times a times c. Use parentheses all over 2 times a. Identify what a is. Identify what b is. Identify what c is. Start using your calculator. The opposite of b over 2 times a. Okay, that's just negative 12 over 6. And that's negative 2. Let's figure out what is in the parentheses here. What's in the square root? What's 12 squared minus 4 times 3 times 13? So inside the square root, don't put the square root down yet. Use parentheses. B squared minus 4 times A times C. Negative 12. So I get the square root of negative 12 over 6. You can't divide this number by this number. One's on the square root, one's not. What we can do is try to simplify this. All right, I'm just going to kind of do work on the side. This is root 12, root negative 1. The square root of 12 is not one of these nice numbers. I don't see the square root of 12. I know 4 goes into 12, though. I know 4 times 3 is 12. 12 divided by 4 is 3. 4 times 3 is 12. So I'm going to write root 12 as root 4 root 3. And I still have that root negative 1. Square root of 4 is just 2. The square root of 4 is just 2. Times the square root of 3, which can't be simplified, times I. 2 root 3i. So that's what root 12 is. 2 root 3i divided by 6. Divide the top and bottom by 2. 2 over 6 is the same as 1 over 3. And this is my solution. Negative 2 plus root 3i over 3 and negative 2 minus root 3i over 3. Here's another quadratic formula. X equals negative b, the opposite of b, over 2a plus or minus b squared minus 4ac over 2a. You can also have it all at once, depending on what your teacher likes. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, B is 6, C is 10. I wish I made B negative. Man, loss. That way, like we practice like the opposite of B. Sorry. I'm better than that. I made this homework after my hip surgery, so I was a little loopy. And I could have done better. All right, so we got the opposite of B, plus or minus the square root of b squared minus 4 times a times c all over 2 times a work inside the parentheses. I get the square root of negative 4 all over 2. What's the square root of negative 4? Well, it's the square root of positive 4 times the square root of negative 1. The square root of 4 is 2. That's one of those nice numbers. Use your calculator to check. Giving us negative 6 plus or minus 2I over 2. Now, if you have it this way, the final step is to divide both of these by 2 to get both negative 3 plus or minus I. 2I over 2I. The 2's will cancel. Okay? Make sure you divide 2 divided by 2. 6 divided by 2. Don't put it as 1/3. All right, let's finish off with the quadratic formula. I'm just going to kind of breeze through this one. Number 10, x equals the opposite of b over 2 times a plus or minus the square root of b squared. I'm just going to do it here. Let's say this is what you guys mostly do. B squared minus 4 times a times c. Negative 16 all over 2 times a. This is negative 8 divided by 4. So this is negative 2 plus or minus. This is root 16 root negative 1, which turns into 4i. The 4 over the 4 cancels to just be 1. Negative 2 plus I, the negative 2 plus the square root of negative 1, and negative 2 minus the square root of negative 1. These are my solutions. Okay, if you plug these into the original equation, it works. Now, plugging in and actually like seeing that it works is actually tough, and that's like something else we can do at a later date. So we're done with the quadratic formula. Let's finish off with the square roots. I know this is a square root one because it's not standard form. I don't see like an ax squared plus a bx. You could use the quadratic formula here. It's just not what I would do. So I would instead just subtract 1, isolate the square root both sides. The square root of negative 1. I mean, if you want to, if this is confusing to you, you can write this as the square root of positive 1 times the square root of negative 1 if you wanted to. And that's just like the square root of 1 is 1. The square root of negative 1 is I. So you just get I or 1I. Okay? Square root of negative 1 and negative square root negative 1 work in this equation. Imaginary solutions. This one is also using square roots. Square root gets rid of the square, leaves us with an x plus 3. We need to simplify the square root of 32. 32 is not a perfect square. It's not one of these nice numbers. I think 16 goes into it, though, nicely. So let's keep that in mind. But I'm going to start, since it's negative 32, by writing square root positive 32, square root negative 1. I need a plus or minus because I used a square root to solve an equation. I'm going to take 32, start dividing it by perfect squares like 16. Oh, so 16 times 2 is 32. So root 16 times root 2 is root 32. Root 16 is 4. Root 2 does not simplify. Root negative 1 is I. 4 root 2I. It is not a nice number that we can combine with x, with this minus 3. Now we have to solve for x by subtracting 3. X plus 3 subtract 3. We finish off with x equals -3 plus or minus 4 root 2i. That's it. You can't simplify it. If you plug that into the original equation, it would work, both of them, but that's tough to do. But like, these are our solutions, and we have to be understanding that. And again, these imaginary numbers show up a lot more in advanced mathematics. It doesn't even show up in calculus. We never use imaginary numbers in calculus, but you keep going beyond more advanced mathematics, they use imaginary numbers. It shows up as things more often. Okay, so hope you don't feel like this is too new or too difficult. Just one little like difference is the square root of negatives being imaginary. All right. Hope we understand this. Please reach out to your teachers if you don't. This is the last lesson. Review day test coming up.